pouvez vous installer, il y a de la place devant.
Il y a deux là. OK. Bienvenue à cette réunion des Python Montréal. Sont, toi, Recurrent, Rhythme. Je m'appelle Olga et je suis heureuse d'être madame de cérémonie aujourd'hui. So, everybody, welcome to Python Montreal 103, Recurrent Rhythm. I'm Olga and I'll be the MC for tonight. Nous allons ici au Halfserious. Je remercie toute l'équipe de nouvelle. Thank you for welcoming us here and at Halfserious. And I just want to apologize for my French. I only started learning in October. Okay. Okay. So how do we? Oh, scroll? Okay. Okay. So you can join the conversation if you would like. Join us on Slack and on our lovely website. There'll be more at the end as well. So, aujourd'hui, nous avons moi ici. Et, après, la présentation de Halfserious par Philippe. Aussi, nous avons la présentation de l'équipe de Python Montréal. Aujourd'hui, on parle de AI, de GraphQL, de PyScript, beaucoup de choses. As you can see, all the stuff is here. I think my French was pretty self-explanatory. And by the way, we'll have a little sort of break in the middle, just so that we can get up, move our feet, and a little bit of break. La pause. Merci de FJNR for supporting us. OK. Notre première présentation sera faite par Philippe Chrétien. Il est associé chez Halfserious depuis 2017 et actuellement est directeur de la technologie vice-présidente. Il va nous présenter Halfserious qui nous accueille aujourd'hui. So first is Philippe. He is the director of technology and the vice president for Halfserious, and he's going to tell us all about it.
OK. Merci d'être venu. C'est le fun de vous recevoir. C'est la première fois qu'on fait ça, recevoir un meet-up comme ça, tout langage confondu. Fait que bienvenue. My name is Philippe Chrétien. I did my first Montreal-Python in 2008, so probably I will guess not many of you were there at the time. And yeah, and another one in 2011. So I presented a small robot activated with tweets, a political tweet. So I was with Yannick at the time, so he invited us to be there. So what about Halfserious? So, oh boy. Non. Fallait pas cliquer. Ah, c'est la roue. Oh my God. OK. Non, c'est l'autre sens. Ouais, je veux ma présentation. Tu l'as mis où? Oh, ben, je n'ai pas besoin. Ben, je voulais parler des projets. OK. Sorry, guys. Okay, but we're a company. We're about 60 people here. We started. Eric always say 13 years ago, but he was alone with Clara, so they were two doing design at the time. We're doing software since 2017, so it's about 8 years. When I got in with them. We have a strong culture, whatever that means. That's a pitch for selling software. So let's get to the next slide quickly. all the project we're doing here are 100% new stuff. So we don't take any existing software and maintain software for other companies. We're fixing problems. So they present us with their problems and we just try to figure out the best way to solve it. These are a couple of our clients. So actually not a couple, it's all of them. So we have clients here in Canada, in the US as well. Okay. So that a couple of example of clients we have. ArcelorMittal, it's a mining company. So we're doing a digital transformation project for them. So they, as you may have seen in many of the projects you're doing on your side, in your respective company, they have like many systems that own their own data and they don't talk to each other. So what we propose to them is to bring all that stuff in a data lake and bring it back then into some data warehouse so that you can cross-reference data from different systems instead of working in silo and then trying to generate reports. So these big companies, they are very report-oriented companies, and we're trying to bring them to the next level where they don't need a report to take a decision, but they can take decision on their data. We also have a project with them to, once we have this infrastructure, so this cloud infrastructure, we build a prototype for an AI project on top of this. So an LLM with a RAG system, Langchain. So we interpret these data using natural language so that they can query their data using this tool. So another project we have, it's with Astuce. So they are selling a fleet management system. Their clients, one you know for sure is Communauto. So they are the fleet management system behind Communauto, and they also have a fleet management system for school buses, the fleet of buses. They have also vehicle in airports. So they track a lot of different fleets of vehicles. So we're doing the same type of project for them. So we have a new UX experience for them for the FMS, and we also re-engineer the backend with them with their team. We're always working with AWS so far, but it's not a religion. It's just a choice that we make. DocMagic, it's a client in LA, so they are selling mortgage documents. So in the US, you have the first bank that sends you a disclosure package, the first package to sign, you have to refuse before to go to the next one. So the faster they are, the better they are on the market. So we help them to generate and convert these documents to digitally signing documents. We also have AutoPrep. AutoPrep is it's a complicated thing, but you take 100 pages document and you find all the signature fields in there, and you generate the document that fits in their own system to sign it digitally. So there's OCR, there's image recognition. So it's that's why I've put it there. It's a very interesting project. We're doing things differently. We always say that. But we're doing the standard stuff, the product design, software development, maintenance. But here we have, as you can see by the place here, we have a very, very strong accent on UX research design. It's very important for us to differentiate on these things. We always say the worst thing that could happen is to very well build the worst solution or a bad solution. So we make sure that when we start coding, we've been through 2 or 3 months of user research to make sure that we have the right solution with our teams. Yeah, that's a new thing. So we've done a couple. It's all pretty small projects, so it's not very big stuff. But all our clients, they really need support to understand what's going on with AI, actually. So it's surprising to see how confused people are, especially when you are at the C-level in enterprise. So they need guidance to decide what's the next best move for them in AI. So we've built for the mortgage guy, we built this RFP response thing. They have to respond to hundreds of RFP each month. So all the questions that are in these RFP, we built an AI tool for them so that they can enter the question. We've trained the whole system with all the documents from DocMagic, so the AI can respond very quickly and they can fill in their RFP response much faster. We're doing the same for sales, PDF analysis engine. Yeah, that's AutoPrep that I presented on the other slide. And AI-driven optimization, that's for the mining company I explained before. So they have a tool that contextualizes the data, and then when it's in a very narrow, we are able to prompt the AI with all the action that the user have done in the UI, so that we can pinpoint exactly what the person is looking for. Instead of asking broad question, through the UI, you select your date range, then you select some action, and at the end, you can chat with it. But we can prompt the AI much more efficiently with this way than we do just by asking questions. No, that's, yeah, communication and services. That's a very, very important part in Halfserious. That's what is it's a key distinction from Halfserious and the other studios. We like to call ourselves a studio, like Eric was working at EA in the past. So that's why we have this kind of look everywhere, but we want to attack the problems with a different mindset, not just doing software for software, but we're trying to solve their problem and engage them in the solution. I'm sure you've worked a lot of time in places where you work on a fantastic software, but when you try to deploy it, nobody wants to use it because they're scared. They don't know how to use it. So all these change management thing, if you bring in the UX team and the designer at the beginning of the project, then it's much more easy. It's much easier for us to deploy the new application and make sure that it's used by everyone. So yeah, that's a proposal we've done for ArcelorMittal, so that when a truck is digitalized, when we're done with a truck and it's all digitalized, we would have a paint job on the truck so that the driver would be happy to have this truck. We're partnered with AWS. Actually, we're in the process of being partner. It's like it's a bit sectarian, so we're trying our best to get there, and we work also with Mina for a couple of AI projects. That's it. I hope that wasn't too long. I don't know what this is. It's QR code.
I added this slide. If
Okay.
you want to follow us on Instagram and LinkedIn, we post content. And we have also job opportunities.
Opening.
Yeah, exactly.
Yeah, so that's us. So is there any question? I guess no.
Any questions from anybody?
No.
No, I'm with you.
Yeah.
PDF analysis.
Sorry?
We talked about PDF analysis.
Oh yeah, sure, I can. I built it. So it's a system. That's the thing I explained. So the problem they have is that very often in the mortgage industry, they are ingesting documents from competitors. So DocMagic has their own documents, but they want to be able to notarize and to finalize document that comes from others, so they can steal their clients. So, but the problem with this is that most of these companies, they don't have any digital signature system. So they generate everything on PDF, on paper, and then it's kind of stuck in the paper world. So what we do with this is that we ingest these documents, so you can scan them. It doesn't have to be a native PDF. You can scan them, send them to AutoPrep, this tool that does the PDF recognition, And then with image recognition and OCR, we can find all the signature fields and prepare the document to be
Okay,
signed.
I'm assuming that the reason you're having these problems is the PDF is really just a bitmap.
Yeah, it can be a native PDF, but most of the time when it comes from the other companies, it's a bitmap. So it's a PDF with an image.
Because PDFs have considerable structure, and it really depends on the tool that made the PDF.
PDF are a mess. Like it's crazy how this protocol has evolved from PostScript to PDF, but it's very messy, and most of them are just an image built in a PDF frame, and that's all. So that's the strength of this tool that we built for them, that you can ingest native PDF or scanned PDF. At the end, we all convert to images, and we work just with the images. So we don't. It's a one more step if we have a native PDF than if we don't.
Okay, fine.
Good.
Okay.
Thanks for your question.
Merci Philippe.
Merci.
Yannick Samuel.
Just make sure that.
If you did happen to scan those links, I do know that currently Halfserious are looking for full stack and front end developers as well as AI engineers. And if you'd like to talk to somebody about those positions, we have Zineb at the back. She's waving. She's wearing the black and white jumper. Okay. 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 So, maintenant, on fait les présentations d'équipe de Python Montréal. C'est Mélanie, notre nouvelle présidente.
Hi everyone. Just to say it in English. Olga improved the French, me I improved in English, but I did my presentation in French, but all the slides is in English, and if you have question, you can ask in English, and I can try to answer and maybe help for other guys on the team. Mais bon, je vais faire ma présentation en français. Donc c'est ça, on s'est dit, nouvelle année 2024, faire un petit point de Python Montréal en cet premier événement de l'année. Et j'ai un peu intitulé ma présentation sur Python Montréal hier, aujourd'hui et demain, vu qu'il y a des changements en cours, que le gars a un peu spoilé pour vous introduire la présentation. Juste pour rappeler, et ceux qui découvrent Python Montréal ce soir, l'association existe depuis juin 2009. Et le but de l'organisation, c'est d'introduire et de promouvoir le langage Python pour n'importe qui est intéressé à ce langage-là. L'idée, c'est de pouvoir partager, apprendre et collaborer avec les membres de la communauté. Donc, vous êtes tous ici, vous faites partie de la communauté de Python Montréal. Merci beaucoup d'être là ce soir. On a à cœur à Montréal-Python de promouvoir l'inclusivité. Donc, tout le monde est bienvenu, quelles que soient les origines, le genre ou le niveau de Python aussi, que vous soyez jeune débutant ou expert Python, vous êtes le bienvenu dans la communauté. Et la communauté cible Montréal, c'est dans le nom, Montréal-Python, toujours mieux. Et donc, dans cette idée, on essaye de faire que les événements sont bilingues. Donc, pour ça qu'on a des présentations en anglais ou en français et on essaye de communiquer dans les deux langages. Donc, voilà un peu c'est quoi l'origine de... Qu'est-ce que Montréal-Python? Et l'association, aujourd'hui, a pu faire 103 conférences. Donc, vous êtes à la 103e conférence. Des conférences qui étaient initialement physiques. Au Covid, où on est passé en mode virtuel. Et aujourd'hui, on est en mode hybride. Donc, vous êtes là physiquement. Puis, on a des gens qui nous regardent en live. Et la conférence va être diffusée sur nos réseaux sociaux. Et en parallèle de ces conférences, c'est des présentations comme on a aujourd'hui. Mais en parallèle de ces conférences, il y a aussi eu 44 autres événements depuis 2015. C'est des événements du type atelier, workshop, donc pour apprendre Python ou pour se perfectionner dans d'autres sujets comme le machine learning. On a eu des sprints de traduction, on a des fiers contributeurs et donc même un contributeur officiel de traduction de la documentation de Python de l'anglais vers le français pour rendre accessible l'apprentissage du langage aux francophones. Il y a eu des hackathons et fut un temps, il y a eu des barbecues. Je vous avoue que je ne les ai pas connus, mais voilà, ça fait partie quand même de l'histoire de Montréal-Python, donc il faut le signaler. Et on a pu, l'association a participé à l'accueil de PyCon à Montréal, donc, qui est la conférence internationale en 2015, donc une petite fierté. Peut-être qu'il y en avait qui étaient là. Moi, je n'étais pas encore sur Montréal, mais en tout cas, c'est un beau succès pour l'association. Et on est une présence aussi en ligne, avec tous ces magnifiques logos, avec notre site web, le Meetup, où vous avez peut-être vu l'événement, le Slack, où c'est là où actuellement la communauté peut vraiment échanger, YouTube, où on peut retrouver toutes les conférences, et puis les traditionnels réseaux comme Facebook, LinkedIn, je dis bien LinkedIn, et Twitter qu'on va peut-être réveiller pour la communication. Donc, n'hésitez pas à nous rejoindre, mais en tout cas, le Montréal-Python se focus sur les événements, puis une présence en ligne. Et tout ça, ça n'est permis que grâce à des bénévoles qu'il faut remercier, des bénévoles qui étaient présents il y a des années. Peut-être que la liste n'est pas exhaustive, j'ai fait comme j'ai pu trouver sur le site. Et des bénévoles aussi qui sont actuellement dans l'équipe. Donc, il y a Doug, il y a Yannick qui est en ligne, il y a David, Jules et Yvan qui sont plus au niveau, qui ont participé à gérer les ateliers ces derniers mois. Puis il y a Noël et moi-même qui tournons autour de l'équipe. Donc voilà un peu l'état de Montréal-Python. Et Olga, pardon Olga, oui, j'ai dit notre magnifique CM Olga, évidemment. Donc voilà, c'est un peu l'équipe actuelle de Montréal-Python. Et comme toute association, l'association évolue. Et une association, ça a un bureau qui est actuellement constitué de Yannick et de Duck, qu'on remercie très chaleureusement pour leur travail. Mais voilà, le temps avance et Yannick nous a fait part qu'il vous souhaitait donner, parce que Yannick est là depuis pas mal d'années, là, je ne vais pas me guesser, peut-être que vous pourrez lui demander en ligne, je ne vais pas me guesser sur le nombre d'années qu'il est là, mais il souhaitait transmettre le flambeau à d'autres personnes. Donc, on a décidé avec l'équipe de reconstituer un bureau et pour ça, pour laisser la possibilité à d'autres gens de rejoindre l'association. Pendant le mois de décembre et janvier, on a fait un appel à candidature pour trouver un nouveau président, un nouveau secrétaire, un nouveau trésorier et des bénévoles actifs pour l'association. Et après cet appel à candidature, il se trouve qu'on a eu une personne à chaque poste qui s'est postulée. De ce fait, s'il n'y a qu'une personne, on n'a pas eu besoin de voter. Donc, je vous présente le nouveau bureau de Montréal-Python. Donc, avec moi-même en tant que présidente, Noël en tant que secrétaire et Duck en tant que trésorier. Toujours là, Duck. Voilà. Donc voilà, on est une nouvelle équipe. On a envie que Montréal-Python perdure, que tout ce qui a été fait puisse servir encore à la communauté et créer de nouvelles choses. Donc actuellement, on n'a pas de prochain événement, mais l'équipe est présente et on va travailler fort pour prévoir les prochains événements. Et même si on est un nouveau bureau tout neuf, tout joli, tout seul, on avancerait moins bien que sans nos bénévoles actifs qui sont déjà présents. Mais donc, on en cherche encore. L'idée, c'est quoi être bénévole à Montréal-Python? L'idée, c'est d'aider à la participation des événements, à trouver des présentateurs, à venir gérer les ordinateurs ou accueillir les gens. On a aussi besoin d'aide pour gérer les réseaux sociaux, pour gérer la communauté qui est en ligne, majoritairement en ligne. On cherche, essayer de remettre la machine en route sur la recherche de sponsors aussi pour pouvoir proposer toujours plus grand à la communauté. Et il faut bien un peu d'administratif. Donc, s'il y a des gens qui sont motivés à faire de l'administration ou des skills en administration, c'est bienvenu. Et surtout, quand on est bénévole, on parle, puis on a du fun ensemble. C'est ça le plus important. Donc, si ça vous tente, n'hésitez pas à venir me voir ou les autres membres de l'équipe que j'ai présentés. L'idée, c'est de faire une rencontre en physique pour justement voir comment on va préparer cette nouvelle année. Donc, vous êtes le bienvenu. Il y aura sûrement des annonces dans les réseaux sociaux si ça vous tente. Le lieu est encore à définir, mais voilà, gardez la date. Mais là, j'ai parlé beaucoup du bureau, des bénévoles, mais Montréal-Python, c'est aussi vous, la communauté. Et dans cette idée, la société évolue et sûrement vos opinions évoluent. Et donc, on aimerait avoir votre avis sur, pour vous, qu'est-ce que Montréal-Python? Comment vous l'évaluez actuellement et qu'est-ce que vous souhaiterez avoir pour le futur? Donc, il y a un petit QR code. Je l'ai affiché un peu partout, puis on va le rediffuser. Mais on apprécierait énormément si vous pouviez nous donner votre avis. Parce que c'est important pour nous de faire ce qu'on aime, mais aussi que ce qu'on aime, ça vous plaise. S'il n'y a personne qui vient nous voir, c'est un peu dommage. Donc, allez-y, lâchez-vous, donnez votre opinion, c'est totalement anonyme. Et puis, on prendra vos suggestions avec plaisir pour faire grandir l'association. Donc, voilà, j'ai terminé. Est-ce qu'il y a des questions?
Are there any questions? No?
Je reste là.
Merci, Melanie. And I'd just like to repeat what Melanie said the last little bit in English, that, Python Montreal, it is about the people that come, and it is about the community, and it is about love of Python. Surprise, surprise. So, if do get involved, and if there are things that you want to get done, if there are things that you prefer, if you don't tell anybody about it, it's not going to get done. So, yeah. Okay. Maintenant, AI part. La révolution Langchain dans les LLM. So we have AI is going to speak to us. It's going to be exciting. Nous avons deux présentateurs, Bastien, Decorte et Rached, Bouchoucha. Rached? I'm so sorry. Rached. Okay. So Bastien est développeur full stack à Halfserious. Et Rached est un spécialiste de AI à Halfserious. And they're going to talk to us about AI. Let's give them a round of applause.
Thank you for being here. I'm going to kick off the presentation, and then my friend Rached is going to take over for the second part. So, AI speaks. Why? Because LLM, large language models, they speak, they talk to us. The Langchain revolution, which is a framework, and we're going to talk about it. It's a different one?
Yeah. It's the second one.
Okay. Okay. Doesn't work. Okay, so what's for the money today? We're going to talk about large language models, LLMs, Langchain framework, and then we're going to have a demo. So, like I said, we're going to give you an insight into the future of development, software development, part of it. So what are they? They're advanced AI algorithm that enables you to basically talk with computers. It's natural language processing. It's part of it. So you can understand, generate text, interact with text. It's a part of deep learning. It's part of deep learning and machine learning with each other, part of AI. And basically, I'm going to give you a quick difference between ML and DL. ML is usually less data. You can understand what's going on inside much more easier. Whereas ML, it's usually much more data, terabytes, petabytes, and considered most of the time a black box. You don't really understand what's going on inside. You know how it's built and how it thinks, like a brain, basically. Like I said, it's built on extensive data analysis, text data only. So its capabilities are text generation, translation, summarization, classification, and a bunch of other things. You can use it for chatbots, coding assistance, and content creation. So some examples of GPT series from OpenAI, probably heard of ChatGPT, Claude from Anthropic, and Llama from Meta AI, so basically Facebook, which is open source. I don't think Claude is open source, and GPT is definitely not open source. So how to use them? You're going to need prompts. Prompts, basically a user input or a machine-generated input. That's going to help you guide your conversation. So its role is very essential because that's how you're going to specify the task that you want the LLM to perform. You're going to give it context, information. It can be documents, can be just the time of the day, where you live, anything. There's two types of them: user-generated, your text, and system-generated. The answer is going to give you. Some example, there's 3 types of prompt. Again, it's a different type again. Subtype, let's say. System prompt, you're going to give it a quick text that tells it, hey, that's what you are, that's your definition. Here I say you're a helpful assistant that answers questions. With that, it's going to know that it's going to answer a question. It's going to be a conversation, most likely, and it must be helpful. Sometimes things like just a word like that matters a lot because that's still the beginning of it. Then user prompt could be, hey, what's the weather forecast for Montreal tomorrow? And the machine is going to use its tools and everything to say the weather tomorrow will be minus 9,000 degrees, and also it will snow. Prompt engineering. It's the art of crafting prompts to get the best result out of it, to make it even faster sometimes and just more efficient in general. Key application is similar to what I said before, question answering and reasoning, and it makes interacting with AI more natural and human-friendly, user-friendly, also more customizable. Beyond the basics, it's also helpful to make it safe. You could tell, hey, do not tell anything about the company. This is out of bounds. Don't talk about that. We don't want to talk about these topics, blah, blah, blah. And it helps you integrate domain knowledge. So everything about your company, your topic, mining, whatever you're working in. And it's very important to have like tailored user-specific interactions. So personalization again. And like I said, for efficiency, accuracy of the responses. Here's 2 techniques. There's many more. I'm going to show you 2 techniques. First one will be zero shot. Basically, just ask something and don't give an example on how to do it. Classify the vibes of a piece of text. Want to hang out, classification, and then it's going to generate what's after classification and the semicolon. Then few shots. Basically the same thing, but I gave it some example. And I'm telling it, hey, this is dope, this is boring. And then if it's a good model, it's going to be able to figure out why this is dope, why this is boring. And it's going to know that it needs to use dope and boring, not positive, negative, short, long, English, French, whatever the classification you're using is. So I want to hang out, again, classification. Yeah. So now Langchain. It's a framework that we're going to use to employ LLMs. So its purpose is to streamline the development of a context-aware reasoning application using large language models. It has 4 core components. Its libraries, both in JavaScript and Python. It's going to help you with component integration and pre-built chains and a bunch of other things that are pre-built that you can just plug in and use. You can really get started with a few lines to get a very simple proof of concept. So there's also templates. You can just copy code some code here and there and customize it to your liking to have it do what you want it to do. LangServe, it's not on production yet, but it's a service of web hosting to have basically REST APIs running your APIs. And Langsmith, see it as Datadog or Graylog, but for your LLMs, for your chains, see what happens, how long it takes, what's the error rate, a bunch of other information. And once more, key application, question answering, chatbots, and this is a bit new, decision-making agents. Rached is going to talk about them later on. So the key components, the LLM, the prompts, and the memory. If you want to chat with an LLM, you need to have a memory. You need to know what was said before by who. You're going to use the memory. Vector store and document loaders, this is for the domain knowledge part. You're gonna store your document, index them with embeddings. We're gonna discuss embeddings today, but that's how you sort of index it and retrieve it very fast. Chains, a sequence of actions, and agents. The agents, they're sort of smart robots. It's like Langchain and Langchain have talked about it before. So let's go with the chains. Like I said, they're basically a sequence of operation to connect different tools, different LLMs, different things, basically. Data sets. It has many advantages. It's modular. You can very easily switch an LLM for another. You're using ChatGPT. No, ChatGPT is the app. You're using GPT, the model, but you want to switch to another model. You can just instantiate a class, give it, I don't know, Claude instead of GPT, and then it's going to use it instead. It's very clear, very simple. Reusability. You can create chains, export them. It's also open source. I don't think I mentioned it. It's an open source project, so you can create chains, have them used by anyone, basically. Observability. It has built-in helpers that lets you see what's going on. You can just see the thinking, the reasoning, everything that's going on, just different steps. You can also see them in Langsmith. And efficiency. With streaming, instead of waiting for the whole answer to be generated, you can just, as soon as it starts getting generated, see it. So you have like a much quicker time to first word. And asynchronous processing. Here's an example, a very simple example. We do our imports, the chain, the vector store, so sort of database. It's going to store the embeddings and then documents. Your documents, your retriever, and then your LLM and your embeddings. So we have a list of documents, very simple, nothing crazy. Oops. We instantiate the embeddings function, the Chroma database, and we just add documents. It's going to do a bunch of stuff behind and index your data, basically. So you can retrieve it after based on its semantics. So at the end of the retriever, I say K3 and score threshold 0.7. That means give me the 3 most relevant documents based on my query. And they must at least score 0.7 of similarity. And then my chain at the very end. Virtual query is a chain that's built in, as you can see, I think it's there. So now let's ask some questions. I'm going to use a chain and invoke with a query parameter query. Who are the hosts? And then which game is good? So you can see Rached, Bouchoucha, and Bastien Decorte. This is this one. And the answer is Minecraft. This is this one. So you just found the most relevant documents, and you could have way more than that. This is just a very simple example. And that's about it for my part.
There's a question here.
Yeah.
I was curious if you're not using OpenAI, is there an open source model that you recommend for embeddings?
So
There's
just
many of them.
Repeat the question so that people online can hear.
Oh, yeah, sorry. So if you're not using OpenAI, can you use an open source model? Of course, yeah, you can. They have a bunch of built-ins, LLMs. I'm not exactly sure how it works, but you can definitely do it. I think it's going to be then running on your own machine, unless you use a different API by any provider. Mistral, OpenAI, Claude, they all have their APIs, but some don't. Some are just giving you open source models because they want to do it. That's also a point of Langchain modularity, being able to easily change from one vector database to another, an LLM to another. We're good?
Yeah, that is good. I do for, in terms of the document objects that you're using for the retrieval, do you know any limitations to the size or like context specific is what I'm curious about?
The size, not really so far. I feel like sometimes they use apps with an amazing amount of data and they're still able to get answer in less than 0.05 seconds, which is very fast. It's really like efficient. They're using like some algorithm to make it way faster, but I think they have like 99.8% of accuracy. So they might miss a document, but they're still very fast. I think you had another question, sorry. What was it again?
No, that was it.
Cool. Amazing. Anyone else? Thank you so much.
So I'm going to start with explaining the drawbacks of using the chains. So basically, the problem with the chains is that everything is hard-coded. I can give you an example that explains why this can be a drawback. So imagine you want to develop a chain that uses an API for weather, for example, and you want it to generate the code that will give you updates on the weather and execute that code. So imagine you say, hey, what is the updates on the weather in Montreal right now? And you can imagine your chain, it will generate the code, and then it will go to execute it. But one thing that could happen is that sometimes it could generate an error when it generates the code, and that happens a lot in the LLMs. Sometimes when your context is so complex, it generates error. So in order to solve these kind of things, you could use the agent, which has more autonomy and more flexibility. I'm going to start with the explanation of what is an agent, and this is the definition that this is how Langchain explains the agent, and this is how they introduce it. And they say the core idea of agent is to use a language model to choose a sequence of action to take, while in change, it's a sequence of action that is hard-coded. So basically, the idea in agent is that we use an LLM that will decide which action it will take, while in change, there is this pipeline that is defined from the beginning. So we add more autonomy in the process of the decision-making. And why this is a very good point? First of all, it has better autonomy and better decision-making. And I think that goes very well with the spirit of AI, which is giving more autonomy to the machine to decide. So now the agent could decide which action to take instead of deciding from the beginning how it should work. It's more adaptable and flexible. And you could imagine very complex use cases. In very complex use cases, chains may not work that well because sometimes you have a lot of corner cases, you have a lot of scenarios that you have to cover. And sometimes with the chains, it's not easy to cover all these use cases. But with the agent, you could cover more of these corner cases or use cases because it's an LLM that will decide which action it would take. So it has better adaptability and flexibility. Also, it allows better error handling and recovery. And this is a very important point because when you want to adapt your LLM to a complex context, as I say, it will generate a lot of errors sometimes when, I don't know, for example, generating an SQL query or, for example, generating a code that will be executed by an executor. So it's very important that the agent could start over and find a solution to the errors it gets. And finally, I think scalability. Agent has better scalability when it comes to scaling up. So if you want, for example, to add a new component to your agent, all you have to do is you implement your agent and then you explain it in the prompt, and then that's it. You could integrate it. While in a chain, you have to find the right place to add your component, and you have also to connect it with the other components. So sometimes when it's a big architecture of a chain, it gets complex to scale up. Now, this is the framework of the agent and how it works. So let's say, for example, we send a query to say, what are the updates on the weather in Montreal, for example. So it starts by thinking, it says, okay, now I have to generate a code that gives me, that will be executed by the executor and uses the weather API, for example. So it goes do an action and it generates a code. And the code, the code, for example, will call a function to get the time right now and to also call the API to get the updates on the weather. And then it will do the observation. So the observation will say, okay, now I have the code, what I should do to get the final answer. And the third will say, you have to execute it. So in the action, it will start over and it will execute that code with another component in the pipeline. And then to get the answer, and then the third will say, now I have to transform it into user-friendly way. So it will go do another action, transform that output into a good text and get the final answer. So that's the chain of thought of the agent, and that's how it works in order to generate the final answer. Here I wanted to give an example of an agent that is developed in Langchain. Of course, Langchain offers many agents, but you could also implement your own agent. But here I wanted to present the SQL agent, which we'll use in the demo. So the SQL agent allows you to communicate with your SQL database, but in natural language. So you give a query, and then there is the agent, which will decide which tool it's going to use. So the tools can be an SQL checker to check if the query was written correctly. There is an SQL query executor, which will execute the code. InfoSQL database gives you all the information you need, like what are the columns, what are their types, and so on. And list SQL database, it will give you the list of databases and table you have. So every time you will ask a query, there is the agent, it will decide which tool to use. There is a prompt also. In the prompt, you explain each one of the tools, and based on the explanation and the context you give, in every action, it will decide which tool it's going to use, and it will do its chain of thought, and then give you the final answer. So we'll do a demo just to explain how this works and show you how straightforward is the code with Langchain. So this is QR code if you want to scan it to get the GitHub for the code, and that's also the link if you want if you are using your laptops. And here's the application. So I'm going to try to explain it. Okay, so that's the interface of the application, and the interface we used Python library also. It's called Streamlit. It's an interesting library. Also, it allows you to develop proof of concept like interfaces very quickly. It's very useful library. And how it works, for example, here I asked the question, just to gain time, I asked the question, how many albums does Alice in Chain have, and gives me the answer. And in the background, what happened is this. Yeah. So in the background, sorry. Yeah. So in the background, this is what happens. So the first action it does, it takes, you see here, it takes the action which says, I want you to list me the table. So it gets all the tables in the database. Now it will do a thought. It will say, okay, now I have the relevant, now I have the tables. I think the relevant tables would be like artist tables and this query, yeah, artist table. And then we'll take an action and we'll ask for the schema for the artist table. So it gets the schema. It will do. It will use another tool from the chain, from the agent, and we'll get the schema of the table. And then it will say, okay, now I have the schema of the table, the artist name. Now, yes, now it wants to check if Alice in Chains was written correctly. So it's gonna use another tool to check if Alice in Chain was written correctly. And this tool, the one that checks if the Alice in Chain, for example, was written correctly, was a tool that we have developed ourselves and we have integrated in the agent. And just to show you that you could develop your own tool if you want to customize your agent. Now it fixed the name of Alice in Chain, for example, was like this, and now it's like this. And then it says, okay, I have the correct spelling of Alice in Chains, and it's gonna start executing the code. So it's gonna generate this select requirement, this select query, and then it will want to see if it was written correctly. So it's gonna get the final select query, fix it, and then it will execute it and give you the final answer. So that's the chain of thought of the agent, and you can see that every time it starts thinking and give you the right answer. And for the code, if I'm not going to go into details in the code, but the idea is that yeah. So this is the main function that you use for the code. Basically, you give the prompt. A prompt it's like you try to explain to the you try to explain in plain text the context to your LLM. So you say all the informations. One of the very important things when you use SQL is to say do not make any DML statements, because sometimes it could hallucinate and create its own like data. And then you create your database. So this is a tool that we have created just to include in the agent. And that's it. You create your agent just like this. It's very straightforward. You give it the LLM, the toolkit, which is the SQL database toolkit, and then you give it the extra tool, you give it the prompt, and so on. And that's going to work. Of course, I can go into details after if you want more details on the code. And I think that's it. I'm going to finish with the conclusion. That's the conclusion. So just I want to finish with the pros and cons of using Langchain and agents. So the process, it facilitates building LLM-based applications clearly.
Can you just put it in full screen?
Yeah, sorry. Yeah, it facilitates building LLM-based application. It supports many features of LLMs like agent, chains, and so on, drag, and so on. It's open source and it's easy to use. But the cons, I think, it's performance limitation. One of the biggest issues, I think, with the agent is sometimes very slow when you have very complex architecture. So that's why sometimes you need to use chains instead of using agents. It has complexity in intensive use cases. And the more you have more tables, like for example in SQL, the more it becomes complex to cover all these tables. And finally, dependence on external modules. I think it's the idea that it depends sometimes on OpenAI, for example, it could reduce its performance. That's it. Those are some resources if you want. And yeah, that's it. Thank you.
Any questions?
Yeah.
Yes. Okay.
What guardrails do you put in place so that your model doesn't just like drop the whole database?
Sorry?
What guardrails do you put in place so that the language model won't just like do a drop at the database? Because that would be like what I would be afraid.
Yeah,
That was-
you have to just say that in the
Could you repeat the question?
You said what you do to avoid like integrating data. That's
You avoid for it to like drop all the data.
Oh yeah. I understand. Yeah, to avoid it to drop all the data. Yeah, you have to write that in the prompt. You have to say never do that. But there are some techniques you could do, like for example, yeah, sometimes you could for example write you must not do that, but you write you must not do that in higher case. So the AI knows that you should not really never do that. Yeah. That's the only reason.
Like 30 minutes, it's gonna stop.
Yeah, I think we could do that.
I still strongly encourage you to have good security on your database.
Yeah.
Yeah,
Langchain.
Yeah.
Also in Langchain, they say try to change the security so it doesn't do that. So you have to modify that in order to avoid this kind of issues. Because sometimes it could hallucinate and create its own data and give you the response and say it's there. So yeah, that happens sometimes.
All right.
I think there was another question.
I think you had one, and then I'll ask the.
Yeah, sure. So, what part of this did you say was, you said for this, I don't know if it was for this demo or something you built before, that you included into this demo?
Oh yeah, it was the part that you check if the names, like for example, Alice in Chains was not written correctly. So you could create your own tool to check if the nouns were written correctly. So it will fix the how it was written.
Okay, so it does look quite straightforward what you've written in your demo, but I was wondering how long did it take to build that component? Was that a big R&D effort? Was it very easy?
No, it was very easy to build. Yes, very straightforward with Langchain. Also, the interface is very straightforward. So yeah, I think both are very straightforward. And yeah, but when it gets complex, that's where it becomes. Of course, that's normal. When it's complex, you have to do all the modification in the prompt, in your chain, in your tools that you're going to use. So yeah, that's when it becomes a bit complex.
How do you define complex?
Complex, for example, you have database, but it's a huge database. There is a lot of columns. The columns could be like weird names, like I don't know, it's just abbreviations. So this kind of issues that would happen. So generally, that's the kind of issue that we have.
Documentation isn't very much up to date.
Yeah.
It's like a new open source project that grew a lot in the past year. There's many things that are not up to date, and sometimes like you have to dig in the classes. You have to go like very deep to figure out. Oh, it's because there's a prompt 4 levels lower that says something that doesn't make sense. I'm going to override somehow.
So my question is a little bit unorthodox. How can you use Langchain to branch on agents according to your specific use case? Is that even possible? Where you use Langchain actually to identify the use case and then select an agent accordingly.
Oh, you mean
is that possible?
You mean an agent using another agent?
Yes.
Yeah, that's possible. That's possible. And I think they added a new feature, which is the Langchain graph.
Yeah.
I think which allows you to do this kind of very complex graphs of an agent calling another agent and so on. So you could do it. Yeah.
And what sort of computational burden or how do you say?
Yeah, it's very costly in terms of computation. It's very costly.
Exponential,
Yeah.
I imagine, because your graph would become more complex.
It gets very expensive.
Okay, thank you.
So that's why sometimes you roll back and you use chains instead of agents, because it will save you a lot of time. So, yeah.
Okay, so there is a cost saving.
Yeah, there is a cost saving.
Okay, excellent. Thank
A
you.
huge one.
Good trick is to have meaningful names for your column and table as well. Like now that you have an engine that works on natural language to query your database, the more information you give in the tables and column names, that helps.
Yeah, I think that was.
Thank you for the presentation. My question would be, is there any methodologies and tools to do testing when building on Langchain?
Yeah, that's. Yeah, you said, is there any tools to use for testing Langchain? I think there is Langsmith, I think. That's the only one that is clearly there to use for testing. Langsmith, it will give you like the tree of the executions it did and how it's thinking inside. I know you could see it in the log, but with Langsmith, it's more easier to understand and interpret. But besides that, I don't think there is something straightforward to say that's how the accuracy of my chain, or that's how performed my chain. So that's, I think, one of the biggest issues. Yeah.
But are you testing Langchain, or do you really want to test the underlying LLM you're using?
You want to test, for example, your whole chain. So you develop the chain, and then you want to test your chain. How
the chain's really dependent on the LLM that you're using.
Exactly.
So you're really testing the LLM.
Yeah, exactly. Many LLMs are interacting, so you want to test that.
Would that be a unit test or an integration test?
I don't think it's a unit test.
So I think there's things like weights and balance, weights and biases.
Weights and bias could help, but not too much. I think sometimes it lacks many features, but could help.
Good.
We have a last question here.
Yeah.
No
more questions.
No more questions?
Okay,
let's
give a round of
Fantastic. Maintenant, la pause. Now we're going to have a 5-minute break. Please get up, walk around, have some snacks, and we'll be back in 5 minutes. We're used to sort of like glass. Everybody, can we let's end our pause, end our break. Thank you, everybody. We're gonna restart shortly. For people in, I want to say in the studio, the people in the studio, if you smell the aroma of pizza, it's because there will be pizza. There will be vegetarian options, I've been told. If anybody here is vegetarian. Okay, so.
More vegetarian than usual. They always underestimate.
Okay, so I think, oh, do we have a, oh, maybe.
Now to GraphQL.
Can we just check that Yannick is okay online?
Oh, this one?
Yes, I think. Could you?
Oh, yeah. You want to share the...
Oui, alors, hop, ouais, donc, est-ce que vous aimez les fraises? Oh, fraises? I mean, strawberries.
Yes.
Just a little humor there. Un petit blague. Okay, so maintenant, GraphQL et fraises, strawberries. Rubens is going to tell us all about it. Rubens est développeur full stack. Il est le développeur principal d'une startup brésilienne appelée 2U qui fabrique des distributeurs automatiques intelligents. So he makes smart vending machines, which is pretty cool. And he is a full stack developer, and he's going to talk to us about this stuff. Let's give him a round of applause.
Yannick, est-ce que tu peux switcher sur l'écran de... Parfait.
Okay, great. Today I'm going to talk a bit about GraphQL and Strawberry. So starting out, thank you for being here. And any questions you guys can just ask while I present. Well, I already got a good introduction, but yeah, basically that's it. I moved to Canada recently. I moved to Canada here last year, and I currently live in Saint-Hyacinthe, and I'm very happy to be here in Montreal. It's a very nice place. Really like it. Really like the people. And just out of curiosity, when I applied to go to Canada, I had to write a letter. And in that letter, I had to explain, like, what are you going to do in Canada? How are you going to, how are you going to contribute to Canada economy? How are you going to be part of, like, the Canadian, people community? And one of the things I put is, like, I'm going to participate in the Python Montreal. So, government officials that are in the... What?
Where are you from, Bahia?
Brazil, São Paulo. São Paulo,
Minas
Gerais. Yeah, from that. And so I still work at this Brazilian startup, but I'm actually searching for jobs in Canada now since I'm here. And let me talk a little bit about what we do, because it really is what motivated me to give this talk. So here this is basically our main thing of the product. It's a fridge that we put cameras in it, and it has a Raspberry Pi. And the person opens the fridge with the app. It takes a picture before and it takes a picture after, and we send those pictures to our AI, and we see how many of the things they took out of the fridge. In this case, they took out 2 Heinekens. We charge them, and that's it. That's basically what our company does. And before we had GraphQL and Strawberry, we actually had a Mongo. It was a Mongo application with a Cherry Pie, which is sort of like Flask. And we rewrote everything to use Python and Strawberry after about 1.5 years of operations. So choosing the GraphQL language was a very, I think, important decision, because after like a year and a half of operation in a startup, you really don't know what you're doing the first year. You're trying new things. You're changing the product a lot. So after a year, choosing something like GraphQL, which has a more of a client-first approach, so you look first at the project and then you sort of go back to the backend, was a very big decision for us, and it worked out. We eventually switched our system, and this is our current stack. That was about 2 years ago. So we use Strawberry and the Strawberry library for Python for serving the GraphQL, Python in the backend with Django. And in the GraphQL, you only have sort of one endpoint, and this endpoint serves our two front-end sites, right? We have a back office site, internal site, and the one for our clients that are made in React. They all query our GraphQL. We have our mobile site in React Native that also queries our GraphQL. And interestingly, we also have our Raspberry Pi inside the fridge that also uses the GraphQL to get data from our servers, and also WebSockets with GraphQL. So we have real-time communication and updates with a Raspberry Pi with our backend server using Strawberry. So it's a very Python-centric startup. You know, we have Python all over the place. Oh yeah, and we have our AI that uses Python also with fast API. So if it's, I think at least this startup is a real like certification that you can build these good and fun technologies with Python, except the front end, it's React, but you can't escape JavaScript, right? Okay, and so another big motivation was after 2 years using Strawberry, I really liked it. It's a very good language. It's very easy to get started. Hopefully, we'll see in the live examples a little bit. And hopefully, after this talk, maybe you guys can try it out. Strawberry, there are other GraphQL libraries for Python. Graphene is the other big one. Strawberry is a bit newer. I think it's more like Fast API if you ever used it. Graphene is a bit more cumbersome. Strawberry, I think it's a bit easier to do things. So it looks a bit more like Fast API, or maybe like even a Flask. And I think it has more things going on in terms of people developing, like the community, than Graphene. I think Graphene, for example, the last update was like a couple months ago. Strawberry, I checked yesterday, I think it was like 2 days ago that they had another new update. So they're always updating, and they have an active Discord community. So it's very easy to just go in the Discord and talk to people and take your doubts. And also they have a Django integration. So if you're already using Django, you can easily set up a GraphQL endpoint. So that is very nice. Okay, so a little bit about the ecosystem of GraphQL. I know that I think a couple of years ago, GraphQL was really hyped up. I think the hype sort of went down after a couple of years, but we can see it's still pretty active. I got this from the GraphQL landscape. You can check it out here. And a couple companies, at least that I know that do it right. We have Twitter, we have Netflix, we have, I think, Twitch, and all these others. So it's still pretty active, and it's still a growing technology with a lot of users. All right. Okay, I'm going to talk a little bit about how it started. I'm going to go a little bit back to 2012 and see sort of what market changes led to the creation of GraphQL. And I think the problems that they have in 2012 are still they're still present today, So I think it's very interesting to see that. So before, in 2012, you had a lot of monolithic APIs. So like Netflix, Facebook, whatever, they had a big monolithic API. And all the clients would start consulting directly on the API, right? So there are a lot of clients, and they're all talking directly to the API. But what happened in 2012? About the early 2020s. You started getting microservices. Almost. You started getting cell phones. So you start getting other types of clients, micro clients, we can say, right? We had cell phones, then game consoles, and tablets, smart TVs, and Netflix was actually having a big of that problem because it's not just one type of mobile device. It's a lot of types of mobile device, a lot of types of smart TVs, a couple consoles. And in 2012, Netflix had 800 different device types. And they were all consulting the same single monolithic API that they built. So you would get, you would try to, with a monolithic API, you would try to make a one size fits all, but in the end, you would just get like different, these are all like theoretical queries for products. You know, you would have to have different endpoints just to serve different specific clients. So your Android TV, you would have endpoint just for the Android TV and whatever. So you could try to fit it. So you could try to fit it all inside the monolithic API. So Netflix was having that problem. They did not solve it with GraphQL back then because there was no GraphQL in 2012. They had to do other workarounds. We'll talk about that later. And another case from that time was, yes. So with all the new use cases, the one size all APIs were getting unviable. So they were trying to move out from the monolithic architecture. Okay. Another problem with SoundCloud, they had two teams, one with front-end needs and their back-end team that had their back-end needs. And for them, it was very complicated that the front-end engineers had to convince the back-end engineers that they can't serve like a megabyte size files to the web app. You know, the web app has different needs than the browser app. And at that time, that caused a lot of conflict between teams because, you know, for every new API, so they wanted to get a new endpoint. They had to they can just be like, oh, make a new endpoint. They had to have meetings and agree on the endpoints and whatnot. And that caused a lot of friction between both of the teams. So that was another point that the monolithic APIs were sort of getting out of hand. It was causing development issues that actually slowed down. You know, SoundCloud, if you look at the reports, they say like this slowed down our production, our ability to make code. And then we had Facebook, which had the similar problems that the other companies had, but basically their mobile sucked. It was really bad. They betted on HTML5 for their mobile application. They're like, no, they're going to use it in the browser, and we're going to serve HTML5 code to them, and it's going to be great, and it's going to work. But no, their mobile was bad. Zuckerberg knew that. It's like we had to do something about mobile, or we're not going to go forward as a company. And 2012 forward, a couple people in Facebook actually drafted what is now known as GraphQL, right? So they did a language, right? So they did a language which, different from the REST API, was designed to be client first. So they describe it as, let's look at our front end. Let's look what the front end people want in a web client, and then we back propagate those changes in the back end. So let's keep the back end and the front end sort of have a middle ground, and that middle ground would be GraphQL. Problem that they had with when we're talking about cell phones and the limits, obviously, to the size, it's a different screen size, but we also have cell phone limits. So when we underfetch, we have in a traditional REST API, we have to get we have to query other endpoints. So if you have, for example, a user endpoint and you also want their wallet, but the user endpoint doesn't return their wallet, you have now to do two queries, user endpoint and the wallet endpoint, or you have to create a custom solution or a new endpoint, or you have to edit your endpoints to stop underfetching, even though you already have those data being exposed for you. And we have overfetching. Maybe an endpoint returns too much data, and now you're using too much cell phone data, and it's bad for the mobile device. So they tried to solve that with GraphQL having a single endpoint. You have one endpoint, and you say the data you want to, you ask for the data that you want. So in the back end, you would have the user, you have the wallet, and we define user and the wallet, and the front end would go, hey, I want a user and a wallet, and not like, oh, I want to query API/user/volume1, wallet/volume2, get the data and match them up. So you would put everything in a single endpoint. That's what they sort of proposed with GraphQL. And they made a schema. So they made a definition, a natural document, which is the definition of the GraphQL schema is in this document. And it would also be independent of the technology. So if you're a Rust developer, if you're a Python developer, you can get you can see the actual documentation and specification for GraphQL. And based on it, you create your own implementation in your language. So that's what they did. And in 2015, in Rached conference, they actually made their ideas public. They showed their documentations, their findings, and they asked everybody to contribute. And from that point on, it just went forward. Okay. All right. I'm going to get a bit more technical, and I'm actually going to see a couple points about about exactly what was this documentation that they released on Facebook for GraphQL. It's called the SDL. It's the Schema Definition Language. So it's basically in their main document. That's what they define. This is what GraphQL is going to be, and this is how it's going to work. So hopefully I can go point by point, and we can see exactly how it works, sort of, and we can try to program some endpoints here live, and hopefully they work. Let's see. Okay. So the first thing that we have that GraphQL defines are the scalar types and the object types. So firstly, you're actually saying the types of data that you have. So here in my example, you have a book that has a title. It's a string. The exclamation point means that you have to have it, right? And then author is a string, price is a float, and then you create first. You define your data first, right? With the scalar types defined. So in the SDL, you only have the Boolean, the int, the float, the string, and an ID. The ID, it can be a lot of things. It can be numeric, it could be a hash, it could be a UUID, but it has a more symbolic importance because it actually represents what the data uniquely. That's what it has to do. It has to represent the data uniquely, just like in an SQL database, you have the main key of the column, right? So that's the thing. And then, oh yeah, you can create your own scalars. I'm not going to do this today, but if the first scalars are not enough for you, which normally they're not, in Strawberry, you can create your own scalars if you want. So in this case, we have our book example. I create an ISBN scalar, right? And to do that, you just create a serialized function. You create a parser, and then you define a type, and you define it in Strawberry. So you can create your own scalars. We use that a lot. One of our scalars, for example, is official documents and telephone numbers. That would be another scalar that it's very common to see, or even like images and other things, right? Okay, so the next is queries. So now that we define our data, we have to.
So it's a quick question.
Okay, yeah.
Could you go back to one slide?
Sure.
So in this process, what is the difference between serialization and parsing? Would you be able to share both?
Okay, so all right, so
serialization and parsing.
Serialization and parsing. One is basically how the data comes in, right? How you serialize the data, how it comes in. So we make sure it's a string. We get it as a string here. and one is how we parse the data. So parsing would be like, for example, if you get a string, I think an example that we use a lot is JSON parsing. You know, we want to make sure that it's a valid JSON, basically, right? So in this case, and at least in this case, our serializer just makes sure that we're in the right format of our input. And here we just make sure that we just validate if it actually fits what we agree upon is an ISBN. So we use it more for validation, right? And this is very interesting. If you actually send the wrong data in the GraphQL query, we're going to see next, it just doesn't work. Like if the GraphQL asks for an int and you send a string, it won't work. It'll be like, hey, you give me some, depends on the case, but like sometimes it just breaks. So if you try to send something that our validator doesn't agree upon, which in this case is a regex expression, simple regex expression, it won't accept the data, it won't complete your query. All right?
Thank you.
Okay, no problem.
There's another question here.
Yeah.
Yes, you have a question. Okay, I'll ask a question. How would the serialization parsing be segmented differently in the case of a string? Would you apply the same? Would the same rules apply, or would it become a little bit more complex?
Well, to be honest, the ISBN, I would have you really. In this case, so you're asking that if we accepted that it was a string,
yes,
would it be more simpler?
Yes.
It would. So the thing is, when you define a new scalar, it's not like you're expecting that a string is gonna come in. You create a new type. So it's like, this is an ISBN. It's not a string. It's not an integer. This is an ISBN, right? And if I don't, and in this case, if I just be like, okay, I'm going to receive a string, I can trust it. It's going to be a string. If I don't do this and I receive, for example, an int, my regex expression is going to fail, and then the whole thing is going to fail. So I think at least when you're serializing, you really have to understand what exactly is going to come in. You got to try to. You don't know exactly what it's going to come in, but you can try to guess your best what it's going to come, and it's probably going to be one of these scalars. Yeah. They're going to be a subtype of these scalars. So it's going to be a boolean, an int, a float, a string. So maybe this parser that I wrote, the serialization that I wrote, if somebody gives me a boolean, it just won't work. Right? If I get a boolean, none of this will work.
In a sense, this is much less robust than the object-oriented case, where your it would simply be a subclass.
Yeah.
So yeah. It's much more breakable. Is that correct assertion?
So yeah, you said that this is more breakable than a class, sort of a class-oriented. Yes, it's supposed to be more functional. It's just supposed to have a function. Get the data in, get the data out. Yeah, without much abstraction. I think if you start abstracting too much, it's gonna be weird. Okay. It doesn't feel right. So yeah, exactly. Yeah, that's a good point. Yep.
So just kind of follow on from serializing. Like I noticed you have type hints in there, but you're also type casting. Just to be clear with how Strawberry works, the type hints are just hints, right? These aren't going to be breaking if inputs don't match the expected type hints.
Well, the thing is, if you're programming in Strawberry, and just because the community really likes typing, you're probably using something that's going to have a very red error and be like, hey, you're doing something wrong. Yes. So technically it won't break because Python type hints, they won't break anything. But
It doesn't introduce like breaking behavior to like not obeying types.
Yeah. Like if you use a cast, I didn't explicitly cast anything here, or if I did like a no question asked to ignore type hints, a type ignore, you would get bad looks. So yes, but that's a good question. Yeah. Anyone? All right. So those were scalars. And with these scalars, we need to grab them, because if we just have data and we can't grab them, it's not fun. So we have the queries. So this is the second thing that's defined in GraphQL. And I separated into 3 different code parts, okay? So this is the actual definition. So let me go back a little bit. Let me go back to here, for example. I forgot to mention this is an actual definition of your queries, the SDL. It's your schema definition. So this is an actual file that's defining your schema. So any GraphQL client, be it in Strawberry, be it in JavaScript, be it in Rust, can read this schema and interpret it itself. So it's like a JSON. You don't have, the JSON is not language specific. The SDL schema is also not language specific. So in this next example, this here would be the definition in the actual SDL document, in your schema definition. You define a query like this. So this query is a shop query where we receive an ID, has an argument. I have to give this argument because I have the exclamation point, and it returns a type shop that we defined earlier. So this is what it would be in my definition. This would be an example query. Based on this definition, I know that this query is going to be valid, right? Based on all the types that we defined, I know that if I go into a GraphQL client and put this query, it is going to work because it's going to be valid. It may not work, but it's going to be valid. So here in this query, we're going to try to query this one that we defined. We ask for shop ID 1, and we ask exactly what we want from the shop. So if you go a bit back, in the shop, we define ID, name, location, and books. So the ID is an ID type, the name is a string, location is another type, location, and books is a list of books. So here, we're only asking for name and location address. So we know that our server is not going to give us all the other things that we don't want. So the list of books, it's not going to give to us. And I think the ID, it's not going to give to us. So we know that the response from our server is just going to give us the name, the location, and an address. And it gives us a response in a JSON form. So this would be the server response. All right. It gives us in a very nice JSON form of data, shop, name, location. So in this case, we get a shop. The shop of ID 1 is called the word. It has a location, and its address is 469 Milton Montreal Street, Quebec, Canada. All right. Okay, this may be a bit too much, but I'm going to implement this in Strawberry, and hopefully, it will start making a bit more sense. All right. How much time? Are we fine with time?
You got 15 minutes.
Oh, I have 15 minutes. Oh, I will copy my code then. All right. So okay. Is the size good? Make it a bit bigger. Okay.
Yeah.
Nice. So basically here, this is already Strawberry code. So Strawberry, it's a code first language. So with this code, it generates the SDL schema, okay? There are languages that do the opposite. You write the SDL and it gives you Python code. There are libraries for that. So you can define the SDL and you get the Python code. This is the other way around. I define it in Python and get the final schema. So here we have our Strawberry book, right? Has our title, author, price. We have our location, okay? And we have our shop, all right? We have this defined. So let me just.
What's the Python library used to convert this to Python code?
No, this is. So what's the library that?
Is it something like SQL Alchemy?
Oh, okay. So okay. That's a good question. I'm gonna get this. So how do I get the data? That's what you're asking.
I just wanted to have you go between the Python and the definition.
All right. So yeah, it's all done by our implementation here in Strawberry. So this is already the Strawberry library, and I'm gonna get into how we get from the database in a little bit. So in the Strawberry library, so this is I have a mock database. I did this mock database with the shops. Okay, has an ID 1, name, location, and it has books. Okay, and has a second shop with ID 2. Okay, so first in Strawberry, you would define the types. So you're not defining how you get the data. You're just defining, I have a book, I have a location, and I have a shop. This I'll go later. This was not supposed to be here right now. And then we define our queries. So I'm just gonna put this in another file, just so we can just have the minimum here. So then here, so we have our book, location, and our shop, okay? And then we define our query, which is what we saw on the last slide. Okay. I'm gonna skip the shops for now, just to make it a bit more simpler, okay? So the next step in Strawberry is we're gonna define our query. And in our query is where we use Python to get our code. So right now, we could use SQL Alchemy, for example, to query a database. So in Strawberry, how would we define that endpoint? Okay, so again, our endpoint that we want to define is this query. This is what we're trying to define here in Strawberry. All right, this shop ID 1. Okay, so we define it using the decorated strawberry field, and it's a Beatles reference. That's the name it catches it. And we define it with a function. So our function receives an ID of type string and may or may not return a shop type. Okay, so it's all typed Python. You have to type it. You cannot not type it when we're doing with Strawberry. And basically here we would put our data. We would put, if we're doing SQL Alchemy, we would use our SQL Alchemy code to fetch the data from our database. I have a mock database, so I just get shop from database, and I get the ID from the JSON I put up in the top. Okay, and then we just put our data that we got, because this is going to be a dict. So this shop data is going to be this dict here, right? And we put it in our shop type that we define up in the code, which has an ID, a name, and a string. And I just use this operator, so it's the same as doing name equals data name, right? It's be the same as doing this and doing one by one until we actually define the shop, right? And so we put this in our data, and we return it if it exists, and if it doesn't exist, we return none. And after we define our query, okay, we put it in our schema code, which is sort of what Strawberry uses to find our query. Okay, so somebody have any questions? I know it's a bit complicated. Yeah.
Me?
Yeah.
Okay. I want to turn to his question. I think it was a very good one. Is it fair to assume that the query types that you're searching here are finite and are predetermined in Strawberry?
So if our query types are finite and predetermined.
Predetermined, yes. He asked this very good question, actually. How do you determine, what was the process of determining those types via your Python
So what's the process? How do I determine the types? Yes.
I think it's very good one.
It's almost, it's just like SQL alchemy. SQL alchemy, you just call a string operator on your table, right? And it gives you the SQL alchemy.
Yeah. So, but the thing is the GraphQL, it's not connected to, for example, the backend code is the backend code. So if we're using SQL alchemy, the SQL alchemy code is in the backend part. The GraphQL is sort of in the middle between the backend and the front end. So it uses our definitions, right, to create a middle language so that we can sort of coordinate the front end and the back end sort of together. Yeah.
I'm just wondering if you can go from this code directly back to your schema and your SDL file.
Maybe we can table this conversation for when we're having pizza.
All right.
We're a little bit getting on in the day, and the pizza's getting cold.
Okay, so
you know,
I don't want to be responsible for cold pizza.
And we still have one more presentation.
So yeah, if you haven't, again, I'm just gonna go really quickly now and show the other things. All right, and if you guys really have any questions, please let's try to talk. I had a hard time when I started learning GraphQL to sort of embrace it. It's a bit different, but please feel free to talk. And the Strawberry has a good Discord community, so you can just go and ask them there too. It's gonna be great. So we have queries to find. The queries can have arguments, like we just saw before with the shop ID. The mutations is just a query that changes data. So if I wanted to add a book to the shop, I would use a query, right? And let me actually I just have to give this example at least of now. Okay, we're already running the server. Okay, so let me just see. So this is called the GraphQL. So this is actually a ways for you to test and run queries that a lot of GraphQL clients come with, right? And this is how you would sort of run the data. So this is our query, right? And we would just execute it, and this would give our results. And our schemas, all the schemas that we defined are here in the documentation for the API. So it's an API that has only one endpoint, okay? It's a GraphQL endpoint. And the way you query the different data out of it is using this intermediary GraphQL querying language, right? So in this case, we have a query where we want the shops with their names, the locations, the addresses, the books with their titles. And we get exactly what we ask for. So if, for example, I don't want the books anymore, I take it down here, remove it, I don't get the books from the query. So I can start to try to customize our query to the way we want it to. And our SDL file that we defined by using the Strawberry that I showed, it will define an SDL file, which is our schema, which in the end serves as our documentation. So here, all of this documentation here in the left was generated just based on the SDL file that we have, all right? So here we have our queries. I defined two queries, a shop ID and the shops. I have our mutations, right? I define a mutation later on, add book to shop. And we have all the different types that we can have in the query: string, location, book, float, int, etc. All right? And this is what, in the end, this is what we're defining with this different, with these different functionalities. Okay, there are a couple of other things. They're enums, they're abstract type. You can use it too. They're unions if you want to use it too. I'm not going to go here into details. And in this, they're federations, which are big GraphQL servers. So the original problem in Netflix, they actually solved using sort of an API gateway. Later on, they solved it using federations. It's sort of, if I could sum it up in 5 seconds, it's a way to use different APIs and different services all under the GraphQL, all under one GraphQL server. All right. So this is a bit more advanced thing to use, but it's a good cause. And yeah, so GraphQL is a bridge between the front end and the back end, basically. So in the case of the server that we have, So our server is Django. So we use Django. We use the Django ORM to get the data from our database, from our SQLite databases, and to communicate with our front ends. That's our mobile front ends, our Raspberry Pi front ends. We use the intermediary. We use just the GraphQL API, just one GraphQL API, and we grab the data just using that one API. So we're not defining a lot of different endpoints. We're just defining a single endpoint, right? That we query independent of what our client is and what the need of our client has. Okay, and these are some of the sources that I researched for this talk. Sorry that we ran out of time. I wish I could have went into more detail. I had to run on the last part, but yeah, that's it. Thanks, guys.
So, do you guys like strawberries? Okay, we have one final speaker, and then it will be time to socialize and eat the pizza and all the rest of the cool stuff. Okay, so let's just PyScript. That's the title. Romain, ici, est développeur web, principalement Python avec Django. He's a web developer. And let's give him a round of applause.
Thanks. So the pizza pressure is on me now. Great. La présentation sera en français, but just for you, sorry, I don't remember your name. It's okay, no problem. You started your presentation saying that you cannot escape JavaScript, and
yes,
you might nowadays with Python. Rubens. So, je vais le faire en français. Je ne vais pas me présenter puisqu'on va aller rapidement. Donc, je m'appelle Romain, je suis développeur chez VNR et je vais vous parler de PyScript, qui est un nouveau projet porté par Anaconda qui permettrait d'exécuter du Python côté client dans le web. Donc, très vite, on va voir l'état actuel du développement web, une petite présentation de PyScript, exemple avec un S qui va devenir exemple sans S, et la roadmap. Actuellement, JavaScript est le langage le plus utilisé dans le monde. Sur 63% de développeurs l'utilisent. HTML, CSS en deuxième et Python en troisième. Pour tout ce qui est chiffres, il y aura les sources à la fin si vous voulez aller consulter. Apparemment, on peut me voir. Sur ces gens qui font du JavaScript, il y en a 50% qui ont un diplôme d'études supérieures en informatique, 19% un diplôme d'études supérieures mais en non informatique, et seulement 28% qui n'ont aucun diplôme. Donc c'est pour montrer que JavaScript est quand même assez réservé aux gens qui ont fait des études supérieures. Et sur le web, on estime qu'à peu près 97% des projets font du JavaScript. Pour ce qui est par contre de la popularité, c'est-à-dire le nombre de recherches de tutoriels, c'est Python qui est largement devant et en augmentation, alors que JavaScript n'est même pas à la moitié de Python et en diminution sur l'année dernière. Je vous ai mis ici tous les liens qui concernent PyScript, donc leur site, Twitter, GitHub et documentation. C'est donc un framework qui est gratuit et open source sous licence Apache 2.0. C'est un projet de Anaconda, qui est une distribution Python. Et ils se définissent comme vouloir amener la programmation à 99%. Donc c'est pour faire un peu écho à ce que je disais juste avant, c'est que leur objectif, c'est que des gens sans beaucoup de formation puissent utiliser, faire du développement web avec Python, qui est très chargé en tutoriels, en communauté, etc. Pour faire fonctionner PyScript, on a besoin d'un navigateur qui supporte le WASM, qui est du WebAssembly. Globalement, c'est tous les navigateurs modernes, Chrome, Firefox, etc. PyScript utilise PyDid, qui est une distribution web en Python qui permet d'installer et de lancer des packages dans le navigateur. Et MicroPython, qui est un Python 3 optimisé pour des microcontrôleurs et des environnements assez contraignants, comme le web. Et pour l'utiliser, c'est très simple. Vous avez besoin d'un tag script pour ajouter la version de PyScript que vous allez utiliser. Donc avec un lien vers le core. Et ensuite, vous utilisez d'autres tags pour dire à votre navigateur, à votre PyScript, où trouver vos scripts Python à utiliser. Donc ça se tient vraiment en très peu de lignes. Ça, c'est le premier exemple que je voulais vous montrer, qui était une image animée, mais ce n'est pas le plus intéressant, donc je vais passer au suivant tout de suite, qui est une visualisation de la répartition des taxis new-yorkais en fonction de l'heure de la journée. C'est juste un peu loin à démarrer, je pense qu'ils n'ont pas encore optimisé le code de chargement, mais voilà. Donc vous avez une carte de New York, vous avez des données Panda qui sont dans le code, et si vous appuyez sur Play, vous avez les données qui changent. Et donc tout ça, c'est fait en Python côté client. Et puis vous pouvez modifier les tailles et les paramètres. Hop. Non, c'est pas moi. C'est la troisième. C'est la quatrième. Parfait. Pour ce qui est de la roadmap, je n'ai pas trouvé beaucoup d'informations. Ils ont surtout de la communication sur leur projet GitHub, donc avec la liste des tickets, les issues, les milestones, les pull requests et les releases. Si vous êtes intéressé par ce qu'ils font, chaque semaine, tous les mardis, ils ont une réunion à 15h30 UTC où vous pouvez poser des questions aux développeurs, aux mainteneurs, vous pouvez participer à la communauté. Et tous les jeudis à 16h, ils font ce qu'on appelle un fun call and demo. C'est les gens qui viennent proposer les projets qu'ils ont fait eux-mêmes pour montrer ce qui est possible de faire avec PyScript. Et la phrase la plus représentative de leur roadmap vient du Cloud Anaconda, où ils expliquent que c'est encore un projet qui est en bêta, qui est accessible. Ils essaient de la rendre le plus stable possible pour que les gens puissent s'amuser un peu avec, faire des projets et que tout n'explose pas à chaque release. Mais que comme c'est un projet en développement, il y a des choses qui vont se casser, etc. Mais c'est très intéressant de voir qu'il y a potentiellement une révolution qui arrive dans le web, c'est-à-dire qu'on pourrait faire du full stack qui sera en fait juste du Python, potentiellement. Donc c'est, je pense, un projet à suivre. Et je vous ai mis les sources ici. Et puis voilà, on peut aller manger. Sauf si vous avez des questions. Mais j'ai découvert le projet la semaine dernière. Je n'ai pas vraiment regardé en détail comment tout fonctionnait. Donc je ne pourrais pas répondre dans la partie technique. Mais si vous avez des questions, on peut essayer. Non, c'était les pizzas.
Merci. So, yeah, I think that's it. Do we have... Just press... Oh, there you go. So, thank you. Merci. Thank you to Halfserious for hosting us tonight. And thank you all for coming. Let's go have some pizza. Allez!